So how you doing folks? Back with another video. So today we're going to be back taking another look at the Sega Master System 2. So in recent videos we've been covering a fair bit to do with the Sega Master System 2. We did a joypad repair, a control pad repair, and we also made an SMS test suite cart. So again, thanks to SVERX, link to the GitHub where you can find the ROM will be in the description. So this was all building up to today's video. We needed this cart in order to calibrate some RGB bypass mods I had done on Sega Master System 2 consoles previously. So I had modded this console previously for someone else, and I plugged it in. I noticed that the picture was kind of dark, it wasn't great, so I knew my levels were wrong. But in order to get the right levels, I needed a baseline to operate off. So in order to figure out the right levels to use in our Sega Master System 2 RGB bypasses, I needed to get a baseline. So with that in mind, I got some 8 and 16-bit Master System, Mega Drive or Genesis consoles, and I decided I would check out and log the RGB levels for all three. I was going to do a Saturn, but it's just too much of a pain considering the optical block and all the other stuff that's in the way. So I kept it simple and kept it to the 8 and 16-bit generations of Sega consoles. So for me, it was important to use the same cable across all the consoles. So here we have a Retro Gaming Cables Sega Mega Drive 2 cable. So Retro Gaming Cables UK are a well-noted brand in the retro gaming community. I have a lot of their cables and they seem to work really well. Fortunately, I did a triple bypass a few months back on my Mega Drive 1, so it also uses the Mega Drive 2 type DIN. So on all three consoles I was going to be able to use the same cable. But with that said, I'd still need to measure, take measurements on this side. So with that in mind, I went out and I got a retro sampling SCART test board. Now these are available from VideoGamePerfection, and I'll leave a link in the description. So with the 240p test suite on the Mega Drive, using the EverDrive cartridge, the SMS test suite for our master systems, and the retro sampling SCART test board, the idea is to break out the scope and take measurements on the console side and on the SCART end and just log them, and that way we'll know what the baseline is for a good signal from an 8 or 16-bit Sega console. So the goal and the output of the project today is actually a spreadsheet. So this project is really all about getting geeky with the numbers and kind of maybe redressing the problems with this console, but also setting a kind of a bar as such for what are good levels. And it's kind of a spreadsheet that I hope we can add to in the future with different consoles, maybe some Nintendo consoles, and just kind of get a overall kind of better picture for RGB levels. So today's video is going to be quite geeky, so you've been warned. We're going to go deep into the numbers as such. Also, I'll have to shoot a lot of it by hand. I won't be able to use my nice overhead cam. So yeah, the lighting mightn't be great. It might be shaky cam at times, bit more vloggy style, but hopefully you get something from it. Well, cool folks, let's get cracking. Okay folks, so bear with me for a second. So we've got our Oscilloscope hooked up. I'm not using channel 1 at the moment, I'm only using channel 2, the blue lead. And on our Mega Drive 2, the PAL one, I'm running the 240p test suite and I have the color bars up for now. And on my retro sampling SCART test board, I've got a Retro Gaming Cables SCART lead, and I'm probing the sync line. So that's what you're seeing here on the scope. Down here I have an open office spreadsheet, with the idea being that we're going to basically take measurements. So there'll be two sets of measurements. This first set will be on the actual SCART board itself. Then I'll open up the console and test the levels and probe the actual DIN itself to get the measurements without the components in the SCART head, the resistors and capacitors that are there that attenuate the signal onto our display. And I'm just using a CRT, my PVM, for now, just because it's easier. I don't want to have a capture setup. So the idea being is this is a stock PAL Mega Drive 2, so I'm going to get the measurements from this. I'll also do my triple bypass, and then I'll start doing some SEGA Master Systems, and that's where our cart will come into play. So here we are again. I'm this time same console, Mega Drive 2. I've got my test bars up there, and I am probing the sync signal directly off the DIN. Using my yellow probe in channel 1 this time, but yeah, 1.7 volts, and yeah, we're going to track it the same way in our spreadsheet here, and I'm just going to go ahead and do red, green and blue. So I've just done the final channel, the blue channel. You can see my results there. I was going to do 3 measurements, but you know what, it's okay. That'll do. So I have my Mega Drive 1 hooked up to the scope here. This is the one with the triple bypass installed, and I just want to get a better baseline. So you can see we're scoping the actual output of the triple bypass as well as the SCART lead. Now this is the same SCART lead that we're going to be using across all the tests, and you can see I have both channels up there. And again, over to our spreadsheet, anywhere where I've done 2 measurements per console, I'll do it directly below and then skip a line before I go to the next one. But you can see I had some trouble getting measuring the sync line, so I did 3 measurements and kind of averaged them for this one below, so I'll probably delete that one. But yeah, it's to get a better baseline so that when I go on to trickier consoles like the SEGA Master System, I'll be able to kind of get a better idea of what's going on. Here's what kind of triggered the entire project that I'm currently doing. We have the SEGA Master System here with the SMS Test Suite cart. This one is my socketed unit. Most of the chips, if not all of the chips, have been socketed, just so I can test other systems. So I have the scope hooked up to the output from Voltar's board, and I also have this channel 2 hooked up here. So moment of truth, I'm gonna flick it on. Okay, so we've got the Sega thing there. Okay, so I'm just gonna go through and do the video test. Okay, so now I've got it dialed in. I've red up on the screen. I'm scoping the red channels here, and I just did a single shot, and you can see, I don't know if you can see it there, it's 1.3 volts on channel 1. That's on the SCART side, and let me just adjust the cursor down for channel 2, which is on the console side itself. So that is 676 millivolts, which is not far off spec. It's pretty good actually. So here we are with another SMS. This one is slightly different. It's something I modded for someone else. So this is the SEGA, the Model 2. But the picture's a little dark on this one. It's not as bright as it should be. So we're starting with sync, and we're going to go through here. Less noticeable maybe on a CRT, but definitely on modern displays you can notice that it's not bright enough. So we're going to go through, start with sync levels, and go through the RG and P chums and see how it differs from the others. So it seems kind of obvious now, but as you can see, I've been probing the output, but there's resistors going to the DIN, and that would explain why my voltage drop there is like 200 millivolts off when we actually get to the SCART side, and that from the probe points it's fine. It doesn't need much calibration at all. So what I'm going to do is I'm simply going to desolder the leads to the board that go over to the DIN. You can see with the little red heat shrink on them, and I'm just going to wire them directly to the pads, and we'll take our measurements again. So I removed the resistors going to our DIN back there. I had kind of put them in for current limiting, not a bad idea, but I just was too aggressive with the values. But with that said, we have a sync signal here, and I'm just going to do a single shot. And I think you can see there, it's 342 millivolts. So again, you can see here before, when the resistors were there in line, it was 190. So you can see I was way too aggressive with the millivolts. So yeah, with those resistors gone, it works perfectly. So the SEGA Master System itself has a slightly weaker video signal, lower in the millivolts than the Mega Drive one, from what I can tell. So yeah, you don't need to be as aggressive with the resistors to get in the range of the right values. Now, I would be happier getting closer, because you can see the average here was above 400 millivolts, but we're very close at 364. It would be nice to hit that 470 mark, but yeah, you know, somewhere 450, you know, another 100 millivolts in this would be nice. But you know what, sometimes you just got to take the win, and I think this is okay. SVERX, thanks for creating the SMS test suite. That's awesome. It's great to have that card. So in the future, when I'm doing RGB mods, I'm probably going to go with Consoles Unleashed, his RGB mod kit for the SEGA Master System 2. Nothing wrong with Voltaire's boards, they're quite good, and they're just more suited to a SEGA Mega Drive than a SEGA Master System, hence all this kind of tweaking and the removing of resistors. Again, my mistake was I placed current limiting resistors going to the port here at the back. There was no real need for those. I could have got away without them. This chart will continue being filled out as I mod more consoles, and yeah, I can kind of figure out the averages and try and stay within kind of spec a lot more with my RGB bypasses. I was pleasantly surprised by my triple bypass, and that one worked out good. So I thought we'd take the time just to quickly go over some of the results in the spreadsheet as we've kind of tabulated them. So we have the Mega Drive 2, the Mega Drive 1 with the triple bypass, the SEGA Master System 2, the version 1 PAL, and version 2 PAL. That was the one that I did for someone else, and it was kind of had the darker picture. So we'll start with the Mega Drive 2. So this one was kind of, I'd say, the most important to test because it's stock. So if we look at the millivolt levels, we have 674, 658, 652. So we're talking about 650 millivolts peak for the RG and B lines. And I've read online, I think in AV forums or even in some of the more archived pages on the internet, that 800 millivolts is kind of the limit. Is kind of, you don't really want to go over that. Then again, analog displays were a little bit more forgiving than our more modern stuff, and it all depends on the video encoder chip too, so you know that plays a part to it. Again, these were controlled because we were using the same cable throughout. The major differences would be on the system side, where we are pushing a different voltage down that cable. But ideally, yeah, around 400 and, you know, I'd say max 500 millivolts on the sync line is kind of where you're looking at. We see our millivolt range for RGB on the Mega Drive 1 with the triple bypass being a little bit higher, but our sync is in sync, I guess. It's 450, and on my second or third measurement it was 460 millivolts. So yeah, that seems like the sweet spot, between 450 and 500 millivolts max. I definitely wouldn't go over 500 millivolts. Consoles seem to be a little different in their sync. Arcade boards and displays, you know, sync signals might go up a little there, but yeah, I think we're pretty much, you know, 460 sounds like a good number for a sync signal. Again, down on our master systems, we can see that they pretty much stay in line with our stock Mega Drive 2, which is pretty good. You can see then on the version 2, the one I did for someone else, those current limiting resistors really did screw with our output signal. We're at 440 here, so once we removed them, we got up to 680, which is, you know, a far better RGB level. My sync level is still a little low. I'd need to test more Master System consoles to see if this is just an outlier. I did go back and redo the measurement a good few times, but yeah, no, it's 364 millivolts, which functionally seems to be okay. I'd be far happier if it was closer to 460 or 470 millivolts. So yeah, I mean, this is a small sample size, and I will be kind of building on this over time. Add, you know, more Master Systems, more Mega Drives or Genesis, and also other consoles like Saturn, some other manufacturers as well, like Nintendo and stuff like that. So, you know, the sample size and that'll grow, and with that I'll probably add more sections, like, you know, what version of the encoders are being used, etc, etc. It'll also be interesting just from a learning point of view, once I try out one of Consoles Unleashed, one of their Sega Master System 2 RGB boards, one of their kits, you know, exactly what the levels are there, because I know Consoles Unleashed has done a lot of this homework already, and probably has tweaked this to an exact amount, especially I'd imagine with the sync. So it'll be interesting to see. That'll probably there'll be a lot to be learned from checking out those levels once we install one of those kits. So today's project was a lot about learning and about getting things right, but also the spreadsheet is something I can build on in the future as I do more mods of the same consoles, and indeed other consoles like Nintendo consoles. It's kind of a learning tool. I will share it, and there'll be a link where you can download it in the description. But yeah, I think it's something that is probably good moving forward, a good learning tool, a good way of kind of getting a baseline for when I'm doing RGB bypass mods. Well, cool folks, thanks for tuning in, and I'll chat to you all again.